In this video, we look at the graph of y equals x squared. It's a parabola, so we're going to look at some of the properties of that parabola. So in order to graph y equals x squared, we can make a table of values. So we can choose any values for x. I chose values around 0. And in order to figure out the y values, we plug them into the equation. So the equation here is y equals x squared. Negative 3 squared is 9. Negative 2 squared is 4, and so on. So now we have a series of points that we can plot. And if we plot those points, we get something that looks like this. A parabola with a vertex at the origin here. What we're interested in looking at is the pattern, or what we would call the step pattern. So as we move from the vertex over one value, how much do we have to move up? So we move over from the vertex over 1, and in this case we need to go up 1 as well. The same is true on the other side. Because the parabola is symmetrical about the axis of symmetry, about this y-axis in this case, the same is true over here. We move over 1 and we move up 1. So we can show that here. Do the same thing, but now from this point that we just found, the point 1, 1, if we're going to move over 1, how much do we need to move up? And you can just count out, 1, 2, and 3. Again, the same thing's true on the other side. And then one more. So from this point, 2, 4, we're going to move over 1 and up 1, 2, 3, 4, 5. So this is what we call the step pattern. So the step pattern here was we went up by 1, we went up by 3, and then we went up by 5. So in this case, the step pattern is 1, 3, 5. Let's look now at a different graph. Let's get rid of some of this stuff, and instead we'll have a look at the graph of y equals x squared plus 2. So the same idea. I'm going to keep the original parabola that we had here. We're going to plug these values here into the equation. Negative 3 squared is 9, plus 2 more is 11. Negative 2 squared is 4, plus 2 more is 6. And so on. So if we were to graph that, those points, we would get something that looks like this. And so what we'd like to do is to look at the step pattern. So what kind of step pattern is there here? As we move from the vertex over 1, how much do we move up? As we move from that point over 1, how much do we move up? And as we move from that point over 1, how much do we move up? So take a moment and have a look at that. Pause the video and restart it once you've had a chance to think about that. You can see that we haven't actually changed the shape of the parabola. We've only shifted the entire thing up 2 units. So the step pattern is in fact the same. Over 1, up 1, over 1, up 3, and then over 1 and up 5. So the step pattern for the graph of y equals x squared plus 2 is 1, 3, 5, and so on. Let's have a look at one more. Let's have a look at the graph of y equals bracket x minus 2, close bracket, squared. So here it is right here, x minus 2 all squared. Same idea, we'll make a table of values. I just chose some slightly different values. Plug a negative 2 in, negative 2, take away 2 is negative 4, and negative 4 squared gives us 16. We can do the same thing for negative 1. Negative 1 minus 2 is negative 3. We square that and we get 9. Plug in a 0. 0 minus 2 is negative 2. Squared is 4, and so on. So you can continue on like that to fill in the table. Here's what the graph would look like. And again, the same sort of thing as before. Notice that we haven't really changed the shape. We've just changed the location on the grid. So take a moment, again, pause the video, have a look at what you think the step pattern might be, and then we'll have a look at it. So you can see here, if we start from the vertex, we need to, when we go over 1, we have to go up 1. From this point now, we're going to go over 1 and up 3. From this point here, we're going to go over 1 and up 5. So the step pattern is still that 1, 3, 5, and so on. Now, just so you don't think that all parabolas have a step pattern of 1, 3, 5, and so on, let's have a look at one that is not like that. So here's a table for the graph of y equals 2x squared So the idea is that we're going to take our x value here, it's negative 3. We're going to square that. Negative 3 squared is 9, times 2 is 18. We do the same thing for negative 2. Negative 2 squared is 4. 4 times 2 is 8, and so on. So this is the graph of y equals 2x squared. If we actually create the graph, you can see that it looks a little bit like this. The vertex is in the same location, but now the shape of the parabola is slightly different. You can see it's a little bit stretched out vertically. So let's have a look at what the step pattern would look like. I'll include the steps here. They sort of look like this. So from the origin, we went over 1 and up 2. And then from this point here, we went over 1 and up 1, 2, 3, 4, 5, 6. So far the step pattern is 2, 6, and if we needed to do one more, it would just be 10. So over 1 and up 10. So the other point here, you can see it on the table, is negative 3 or positive 3 and 18. So we would have to go from 8 to 18, so that's going to be up 10. So here the step pattern is 2, 5, and 10. So it's actually twice as big as the other step patterns that we looked at. So that's a quick introduction to the patterns found in the graph of a parabola and also in the tables.